Alright guys, we got today's review going with Chapter 1 on page 1 of your semester review. First, from this picture, name 3 collinear points. If I'm going to name more than 2 collinear points, I have to see the line that they're on. The only points that I see that are on the same line are A, B, C, and D. So it says name 3. I'm going to put all 4, A, B, C, and D. You can use any 3 of those points and say that they are collinear. In order to make up a line, we need at least 2 points. To make a plane, we need at least 3 points. On the next picture, what is the intersection of plane ABC? So plane ABC would be here on the top, and plane BFE, which is the back. So where those 2 planes come together, let's get rid of all that drawing. Where those 2 planes come together is right here, and that is along segment BC. So that is the intersection of the 2 planes. Anytime 2 planes intersect, they intersect in a line. Now here we named a segment, but remember a segment is a part of a line, and since this box doesn't go infinitely, we just called that a segment. But that segment is on line BC. When 2 lines intersect, so you just have 2 lines crossing each other, their intersection right there is a point. What is the length of segment AB? We can just count each space. 1, 2, 3, 4, 5, 6, 7. So it's 7 units long. Find the approximate length and midpoint of these 2 points. Okay, so for length, we're going to use the distance formula. Okay, so the distance formula is x2 minus x1 squared plus y2 minus y1 squared, all under 1 radical. Okay, so the x's are the first numbers, the y's are the second numbers. It doesn't matter which order I do this in. So for x minus x, I can do negative 4 minus 3 squared plus, and then y minus y, 7 minus negative 8 squared, all under 1 radical. So negative 4 minus 3 is negative 7. 7 minus negative 8, minus negative means plus, so that's 15. Negative 7 squared is 49. 15 squared is 225. And when I add those together, I get 274. And then it does say approximate. So I'm going to type in my calculator square root of 274, and that's about 16.6. So there's my approximate length. It also asks for the midpoint. So the midpoint formula is x1 plus x2 divided by 2. And y1 plus y2 divided by 2. Okay, so the x's are negative 4 and 3. Negative 4 plus 3 divided by 2. And the y's, 7 plus negative 8 divided by 2. Negative 4 plus 3 is negative 1. And 7 plus negative 8 is also negative 1. So there's my midpoint, negative 1/2, negative 1/2. If JKL is 100, then I know this angle plus this angle is going to equal 100. 8x plus 1 plus 5x minus 5 equals 100. My like terms are 8x and 5x, that makes 13x. 1 and negative 5 makes negative 4. So I'll add 4. And I'm going to rewrite that over here. 13x equals 104. And divide by 13. 104 divided by 13 is 8. It does not ask for the value of x. If it does ask for the value of x, I'm going to choose 8. But in this case, it asks for the measure of each angle. So the measure of angle JKX is 8 times 8 plus 1. That's 64 plus 1. This is a 65-degree angle. The measure of LKX is 5 times 8 minus 5. That's 40. Minus 5 is 35 degrees. So these are my two angle measures. Now to double check and make sure they're right, I can do 65 plus 35. 5 and 5 is 10. 1 plus 6 is 7. Plus 3 is 10. So that gives me 100 degrees like I started with. So I know that my two answers of 65 and 35 degrees are correct. To find the complement of an angle, complements add up to 90, so 90 minus 34 is 56 degrees. Supplements add up to 180, so 180 minus 67 is 113 degrees. Okay, these two angles are complementary, which means they add up to 90. 2x plus 6 plus 3x plus 4 equals 90. Like terms are 2x and 3x, that makes 5x. 6 and 4 makes 10. When I subtract 10, I get 5x equals 80. And then I can divide by 5 and find that x is 16. It does say find the measure of each angle, so I need to plug that in. 2 times 16 plus 6, that's 32 plus 6, which is 38 degrees. For angle WER, and for angle FGH, 3 times 16 plus 4, so that's 48 plus 4, which is 52 degrees for angle FGH. Now when I add those two together, I get 10, and then 3 plus 5 plus 1 is 9, so they add up to 90 degrees. So I know these two angle measures are correct. Okay, from this picture, name a pair of vertical angles. Vertical angles are directly across from each other, like angles 1 and 4. That is the only pair of vertical angles in that picture. Next is adjacent angles. Adjacent angles are any two that share a side and a vertex, like angles 1 and 2. I could also do angles 2 and 3, angles 3 and 4, angle 4 and 5, or angle 1 and 5. And then a linear pair. A linear pair is adjacent, like all of these, but they also have to make a straight line. So if I look at each pair of adjacent angles, 1 and 2 do not make a straight line. 2 and 3 do not make a straight line. 3 and 4 do not make a straight line. 4 and 5 do. Angle 4 and angle 5, when I put those together, they form a straight line. Angle 1 and 5 also form a straight line, so angle 1 and angle 5 is also a linear pair. On page 2, we'll start chapter 2. Write the statement, soccer players are athletes in if-then form. So in if-then form, if you are a soccer player, then you are an athlete. Then write the converse. So the converse switches the if and the then. If you are an athlete, then you are a soccer player. Okay, let's assign a truth value to these before we go on. If you are a soccer player, then you are an athlete. I would say that's true. Soccer is an athletic sport, so if you are a soccer player, then you definitely are an athlete. That is true. If you are an athlete, then you are a soccer player, I would have to say that is false. There's a lot of things that you can be other than a soccer player if you are an athlete. Next is the inverse. We go back to the original if-then and negate the if and the then. If you are not a soccer player, I'm going to abbreviate to make sure it fits. If you are not a soccer player, then you are not an athlete. I would have to say that's false also. There's a lot of things you can be other than a soccer player to be an athlete. And the contrapositive. We go back to the original, we switch them and negate them. So it's like putting the converse and inverse together. So if you are not an athlete, then you are not a soccer player. I would have to say that is true. If you're not an athlete, you're not going to be able to be a soccer player because that is an athletic sport. What can you conclude from the following statements? If you are a poet, then you are a writer. You are a poet. What you can conclude is you are a writer. Draw a line segment LM bisecting XY. So it is LM that is going to do the bisecting, XY, is going to be bisected. So here's segment XY. Here's the midpoint of it. LM has to go through that midpoint. As long as LM goes through the midpoint, it is bisecting XY. On to chapter 9. The image of point P, negative 2, 4, under a translation where we add 4 to the x and subtract 3 from the y. So that's going to be point P prime. Negative 2 plus 4 is 2. 4 minus 3 is 1. The next one on the exam, you may use patty paper, some kind of tracing paper, and it's going to be kind of hard to see on here, but you're going to trace STUV onto your paper, and then you're going to rotate it around the origin. So you have to trace it and trace that origin. Okay, so when I trace that onto my paper, I can then turn it. That's 90, 180, another one would be 270. Okay, so 2 turns. Probably weren't really able to follow that very well, so if I turned it once, that's 90. 2 turns is 180, so I'm going to be over here. Okay, so then I could name these coordinates. S prime is at negative 2, 2. T prime is at negative 2, 3. U prime is at negative 4, 1. And V prime is at negative 4, 4. So if it was in this range, it would be a 90-degree rotation. If it made it all the way around to here, it would be a 270. So this would be 90 degrees, 180 degrees, 270 degrees. Reflect the figure over the y-axis. Here is the y-axis. I want to reflect over that, so A is 1 to the left, so A prime is going to be 1 to the right. B is 3 to the right, so B prime is 3 to the left. And C is 2 to the right, so C prime is 2 to the left. How many lines of symmetry? I see one here, 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 and here. That's 4. Then 5, 6, 7, and 8. It has 8 lines of symmetry. All right, continuing with chapter 9, what rotation will map this onto itself? So how many degrees of rotation? I could turn it here and here, where it's going to go back onto itself. That's 2 turns to make it go all the way around. 360 divided by 2 is 180 degrees, so it's a 180 degree rotation that will map it onto itself. So I would call that a 180 degree rotation about the center of the figure. That's the rotation that rotates it or maps it onto itself. Okay, find the scale factor of the dilation. So what I can do is take point B and find out what would I have to do to point B to move it to B prime. So point B is at 2, 2. Point B prime is at 4, 4. So what I have to do to get from B to B prime is multiply by 2. So the scale factor of the dilation is 2.